Hi, y'all. It's Mary Esther here, and we've got Alison Norman from the Department of Computer Science. And Alison's going to talk to us today about what she works on in our department and how everything comes together. So, Alison, tell us some about yourself.
I'm Alison Norman, as you just heard, and I teach in the computer science department. I teach the operating systems course, and I also used to teach the ethics, one of our freshman ethics courses for the camps. I taught the labs, or I teach the labs for the First Bites camp, and I am involved in the Women in Computer Science program. I'm involved in K-12 outreach, and I'm the associate chair for undergraduate education.
What is your education background?
Well, I grew up in rural Georgia, and then I went to Georgia Tech for my undergraduate degree, which was in computer science. And then I came to UT Austin for graduate school in computer science. And I earned both my master's and my Ph.D. Here at UT Austin.
Your family is also full of computer science people, right? Tell us about that and if it influenced you.
I cannot say that computer science was a unique idea in my family at all. My father was a computer science professor. He's retired now. My mother was a computer programmer. And so which is super strange for someone as old as I am, to have both parents be involved in computer science. So yes, both my mother and my father were computer scientists, or I don't know if you ever really stopped being one. Did have an influence on me as much as I tried to not let it, right? So I wanted to do something unique. I did not want to follow them into computer science. And so when I went to college, I majored in biology because for me, but I had already been introduced to computer science. I was actually initially introduced to programming in high school, also very unique for my age. I had done an internship in an astrophysics lab where the professor in charge showed me a list of projects. And he said, "What project would you like to do?" And I looked through the projects, there were like 5 of them. And it's like a bunch of astrophysics terms I didn't understand, bunch of astrophysics terms I didn't understand, et cetera. And then the last one was about coding. And it turns out I didn't understand what that was either, but I didn't know it. I thought it was encryption. I don't know what I thought the astrophysics labs were doing, like, I don't know, encrypting messages to aliens maybe. So but I was like, I'll do that. Code sounds fun. I really had no understanding of what code was at all. And so it turned out I had picked out a project where I had one code base in Fortran and another code base in Fortran, and I was merging the two so that they could work together. I learned quite a lot that summer. And I really liked it. And the next summer I participated in, it's kind of similar to this actually. I went to the program for women in science and engineering. It was at Iowa State. And I worked in the electrical and computer engineering lab there, programming mobile robots. And they had, this is like we had to solder them together. But we soldered these robots together, and then they had sensors on them, and we could program them to follow us around because, Iowa air conditions a lot like Texas does. And so if you're 98.6 degrees walking around the room, the sensors could follow the heat of your body. And I thought, well, this is just really cool. I can teach this robot to do all kinds of things. And then I had seen how useful programming was in the astrophysics lab. And I was like, this is great. So when I got to Georgia Tech, I majored in biology, but then I wanted to take computer science classes, and I couldn't because it was a closed major. So I declared it as a double major with no intention of actually majoring in it. And then I took only computer science classes. Like, I think I only took the biology intro sequence. I don't think I ever took another biology class after that. But so I only took computer science classes. And then somewhere around my junior year, I finally admitted that I was not going to go back and ever do biology. I was just going to stick with computer science.
I bet your parents were proud. What was it like then coming to UT Austin and getting your master's and your PhD here? What was your focus too?
My focus been the system part of the, well, this, so we have this idea in when we talk about computer science that there's like the systems area, and that can be a little strange from the outside, right? Because it seems like all computers are completely systems. So, so to explain that a little bit better, it's like the hardware and the operating system, that the pieces of software that actually make that hardware work and then support the applications of the user, that's the part of the system that I like. And in particular, so the hardware, the architecture of the system, the hardware is also part of systems, but the part that I particularly like is right in there in the operating system. And because the operating system, it's like it decides, it really affects the way the user feels about the machine. It's what decides, like if you, let's say you have a machine with a processor in it, right? And your processor can only execute one thing at a time. But very often as users, we're trying to execute a lot of things at a time, right? And so the processor gives us this illusion that all these things are executing at once, when it's actually only executing one thing. And a lot of our systems now have have the ability to execute more than one thing at a time, but it's often like four, right? We're still trying to execute 16. So
Right.
these sorts of policies and the way it affects the user, like I really liked that piece. And so I got involved with operating systems at Georgia Tech. I actually was an undergraduate TA there. And I feel like that experience really helped form my goals in a lot of ways. I loved teaching and I loved being an undergraduate TA for operating systems. And at UT Austin, I make a lot of use of undergraduate TAs because it was so important to me. And so I really liked systems there, and I went on and I took advanced operating systems and embedded systems, right? Just real small systems that control I mean, there's embedded systems in your microwave and all those sorts of things. I took those. I thought they were really cool. And then I came to UT Austin and I kept studying systems. My focus changed a little bit. So I came to UT Austin as a PhD student. One of the things that a lot of people don't know is that you do not have to have a master's to go to a PhD program. You can go directly to a PhD program. And I wanted my PhD. I wanted to be I wanted to be a professor and teach in academia. I've always wanted to teach. And so I wanted that PhD so that I could do that. And so I came as a PhD student, and after some amount of time, I started working on my thesis topic, and that's like, finding a thesis topic is like a whole separate story. But there, I was working on. So we have supercomputers, right? We actually have the fastest fastest academic supercomputer in the world, just up the street at the Texas Advanced Computing Center. And these supercomputers. These supercomputers now, so it used to be the supercomputers were specialized hardware that were built that were just one machine, right? But it was very specifically done to be a supercomputer. And now supercomputers are built out of parts that we can all buy, right? And they take a whole lot of these parts that we can all buy and they connect them all together. And so like, I think, well, I shouldn't guess because I'm going to get it wrong, but I'm going to do it anyway because that's what I do. So I think that there's like 578,000 processors that are processing cores that are part of Frontera, which is that really fast supercomputer. And so each of those processing cores can run an application basically. But what they do is they run an application on maybe each of those cores as one big problem, and then they communicate, that the applications communicate their answers to each other so they can solve the problem. the trouble is that if you connect all of these machines together, it's likely that one of them is going to fail at some point in the computation. And then your application has to be able to deal with that failure, right? Without having to start over. So these machines are used, right now, they're being used on experiments to figure out a COVID-19 vaccine. They are also used for hurricane prediction. They're used for earthquake prediction. They're used to test the stability of our nuclear weapon stockpile, so we don't have to do so much nuclear weapon testing. Like there's a lot of important applications that run across these machines, but they can run for days, right? Trying to understand the science and trying to execute their algorithms. And in the course of those days, right, a machine could very well go down. Like this isn't a fast application that we're talking about. And so my research was all about preparing the application that was going to run across those machines to be able to recover from those failures so that they could continue making progress. And I had a ton of fun doing it. It was also a ton of work. But you know, you get to pick your own problem to work on, and so that was really nice. You basically get paid to work on the thing that you chose.
Now, during the time,
Yeah,
during the time that you were getting your PhD, were you also teaching then? I wasn't sure of the sequence. Yeah.
So I wasn't teaching. I was a TA. I was a graduate student TA at that point, and I TA'd in our intro courses, basically. So now so the curriculum has changed since then, but the course I was TAing was basically what is now our second course, 314 data structures. And so when you're a grad student, so PhDs in computer science are typically fully funded. So you don't pay any money. Like my tuition was covered. I was getting a monthly stipend that covered rent and food and, you know, car maintenance or whatever. And I could fly home to see my family, all those things. As part of that, you're either typically a TA, a teaching assistant, or an RA, a research assistant. And I spent most of my time while I was getting my PhD as a teaching assistant. There were some times when I was an RA, a research assistant, and what I found is that when I was removed from the classroom, I lost some of my motivation to finish the degree, and so it really kept up my sort of general level of happiness to be TAing at the same time I was doing that research.
Tiffany, you have some questions?
Alison won't brag on herself, so I will brag on her and let everyone know that as a teacher, she wins all the awards. She won the President Associates Teaching Excellence Award. She won the Regents Outstanding Teaching Excellence Award. Our department's really proud of Alison and so happy to have her teaching and doing so many more things with us. Alison, why did you decide to teach as opposed to going to industry and making millions of dollars?
I love teaching, and I don't know that I could have gotten away from it if I had tried. When I was young, I ran a school for my sister and her friends on the weekends. Well, a friend of mine and I ran it together. It was called Young Learners School, and we had worksheets, and we had spelling tests, and we had attendance charts and gold stars. And it was every Saturday morning, I think. If you talk to my sister, she will tell you that I was her first and toughest teacher. I mean, I made her practice drawing a decimal because I didn't think she drew it correctly when she was 4, right? Sheets of decimals. But I loved that. Like I loved teaching, and I think that, and then I had this undergraduate teaching experience, and then I came and I liked being in the classroom, and so I think that I was just gonna basically do whatever I had to do to be able to teach in the environment that I wanted to teach in, and I love it. Like I love helping people understand. I love watching watching the understanding come, I guess, as they the dawning of understanding. I love helping students get to where they didn't think they could go, right? So my class, operating systems, is a very, very difficult class. And that's just like learning what the operating system is doing is hard. It's doing a lot of things, and it's very different from anything you've learned before. So there's not a lot of knowledge you can build on from the beginning. You have to build it up from the bottom. And a lot of students will come into my class now and they'll be like, oh, this is like, I'm not sure I can do it. Like I don't know about operating systems, you know, and they can, and by the end, right, they have a lot of which they can be proud because they learned so much and they were able to reach a bar they did not think they could reach.
Besides the operating systems course, you teach an interesting ethics class to freshmen. Can you tell us why that's so important for computer science majors?
Yes. So Sarah Abraham, another person who teaches in the department, and I co-developed a freshman ethics course, and I actually was not able to teach it this year. There was a conflict, but I got to teach it the first 2 years that we had it. We developed this course because we felt like it was so important for students to start realizing the societal impact of software, and to start realizing how easy it is to build our own worldviews into software from the beginning. And so we really wanted to open that conversation up as students arrived on campus, or at least in that first year when they got to campus. So we have, like, I talk about ethics in my operating systems class, and Sarah teaches an upper division ethics class. And a lot of times we got feedback. It was like, oh, this is the first time I thought about the real world impact of these decisions. And we wanted to change that. We really wanted to start talking about it ahead of time. And we look at bias in algorithms, and we look at we look at things like, whose responsibility is it, right? So if you're writing the software, is it your responsibility to speak up if you think the software is doing something unethical, right? Or do we get to leave those hard decisions and that difficulty speaking up to somebody else? Be like, I'm just the programmer, right? We talk very much about how you don't get to do that. You're writing the code. The responsibility ends with you. You are responsible for your code, and you're responsible for your code. Not just like, you shouldn't program an app that's going to tell, that's basically going to tell everybody that I can't think of a good example. Tell everybody that uses it, right, that they need a particular drug or something. You shouldn't write that kind of application. But it's also your ethical responsibility to make sure that the code you write is not going to introduce is as bug-free as you can make it, so that it doesn't introduce insecurities into the system, and leave your users vulnerable to computer viruses, and also to make sure that it's good code, and it's, if you're programming the braking system of an automobile, that it's going to work when the people go to brake.
The department has always been very interested in bridging the gap of women in the department. So when I started, we were at about 10% women. I know our entering class this year is 35%, which is fantastic. And that's always been a cause dear to your heart. Why is it important to bridge that gender gap? And also, what have you done in the department with a team to make some changes?
Yeah, so it is very important. So I think that one of the ways that we can create better software, and that computers have the ability to change the world, right? We have seen that they are changing the world as we speak. But computers are only solving the problems that of the people who write the software, right? Like if you don't know the problem exists, you do not have the ability to even try to solve it. And so as a result, we really need to make sure that there are people in the room making the decisions, and there are people with that both understand what software can do and see the world from a different perspective, right? That are in the room making the decisions that can drive this software. So I really think that it's important from like a world-changing perspective, and doing the best by society and by our fellow humans. I also think it's just sort of important for women in general, right? So this is a fantastic field, right? We get to change the world, we get to solve puzzles, and we make a ton of money doing it, right? And so I think that the opportunity to participate in this field that lets you do that is incredible, right? It can give women financial independence, which can be very, very important. Also, there's a lot of flexibility in this field. And so a lot of people are very concerned about having careers, right, that will fit if they want to have children or if they need to take care of other family members. And this field has a lot of flexibility, right? Like so we're in the middle of a pandemic now, everybody's working from home, but before that, if you needed to work from home because a kid was sick, or if you needed to work some in the evening because you had to take a kid to a doctor, like, okay, it was all fine. It's a very relaxed field in that sense. And I think so I think that having women involved in the field not only, helps change the world in a positive way, but also can really benefit their own lives.
And do you want to talk about any of the initiatives in the department that you've worked on?
There has been a concerted effort in the department to recruit women, to expose women to computer science, to recruit them once they're interested, to come to our department, and then to make sure that they are happy and supported once they are here, and that they successfully graduate and move on to the careers that they want to have. And so as a department, we've been running these camps for a long time to expose more women to computer science, and to provide them with more experience, and to in some cases, particularly now as more high schools start offering programming, one of the things that we're doing is we're really saying, hey y'all, programming is our tool, but look at all the things we can use that tool to do. And so then we can get involved in, like, the graphics, the graphics world, or the robotics world, and you can sort of introduce people to that idea, the scientific computing world, right, that I was talking about before. And so we also, as a department, we have outreach. We have 3 different outreach organizations in the department, so the students can get involved and sort of can base their level of commitment off of what else they have going on that semester. We have a roadshow that goes out to schools to introduce computer science for an hour, and that's sort of sporadic based on school demand and when they want to go. We have Coding in the Classroom, which goes out to a classroom for 7 weeks in a row, and teaches something about the importance of computer science. It teaches some programming, and we have these Mindstorms built up like Wallies, and they teach the Mindstorms to dance, and then they show off their dance, the kids. That's aimed at 4th and 5th graders. And then we have, and sometimes also early middle, 6th grade. And then we have a Code Orange, which uses programming really as a tool to mentor students. And so they have one-on-one, you go every Friday to an after school program. And in the process of teaching the kid to program, you also talk about things like study skills and navigating the world and all of those things. So, so we have those outreach initiatives to make sure that people are exposed to computer science. And then once they're in the department, we have the Women in Computer Science group that is very active. It provides support it provides career support, helps people build resumes, does technical interview prep, introduces women to companies. They have company sponsors that come in. There's also a corporate mentorship program. You can be paired with one of our local alumni, right? One of our local women alumni to learn more about their job and to learn more about the corporate world. We also have graduate mentorship, where you're paired with one of our graduate women to learn about graduate school. And we have things to help our women meet the faculty. We have faculty women lunches. So we do lots of things in the department. In addition, we also our faculty have been trained, and we are doing this on an ongoing basis, have been trained on the disparate impact that women may face in the tech industry, and as an underrepresented group in the department, and they have been trained about why that matters, and also how to mitigate any effects of that impact. And we have similar training for our TAs and our student org leaders. And then we also, we have last past year, we started a male ally training to help our men understand what it's like to be underrepresented and how they can help.
You have a lot of energy.
I have a lot of help.
You do a lot of good work for the department, a lot of outreach, and it's so fun to work with you on the camps. When you decided to come into the My Camp world and created Project Illuminate and Project Lightcraft, what inspired you to create that particular challenge for the campers when they do get to come to campus?
Yeah, so Project Illuminate and Project Lightcraft both have the same basic idea, where you're learning to program by changing something in the physical world, right? So in these projects, you learn to program by flashing LED lights, and you can change the colors of these lights. Like think about, like a strand of light bulbs. You can change the colors in these lights. You can change how fast they how fast they flash. You can set it to music and make the lights dance. And for me, it's very much like, okay, so first of all, it is super exciting when you're learning to program and like you get it to print out "Hello World" on that screen for the first time. But as you're learning more complex things and you're looking for a project, it's really nice to be able to touch it, right? And to be able to see something change in the physical world. I just think that's really cool. And so for me, having these projects where you could combine the creativity of the programming, right? So you got to choose the colors, and you got to choose how fast they flash, and you got to choose what song you wanted them to dance to, right? Like that's sort of like, there's so much creativity in programming, and that really captures it, right? It captures the way you.
It's absolutely the most fun project I've watched in the lab. If you're interested in creating your own project Illuminate at home. We do have instruction. You might have fun with that as a project for a
Yes.
rainy day.
Yes, and you certainly can. That's how I came up with the project in the first place.
So, Alison, we've worked for years together on the summer camps, and I was just thinking back to a couple of the times when you brought your kids with you to the lab. Tell us more about that experience or those experiences.
Oh, yes. So I teach in the department, and one of the things that I do is I refuse to teach in the summer. And so I don't typically have a lot of childcare in the summer. And so sometimes when I'm teaching the first bites of the Code Longhorn Lab, my kids are there too. Other times I'm able to leave them with my parents who live nearby. But yeah, so I have 3 children. I have 2 boys and a girl. And by the end of the summer, we're right in the middle of birthday season, but by the end of the summer, they will be 13, 9, and 6. And they've been hanging around the camp for a really long time. I did my first camp the year Benjamin was turning 1, I think, in 2012. And then there was another camp, the camp in 2014. Catherine, my youngest, was 5 weeks old, I think, at the camp. And I had various family members in and out helping me take care of her. It was a wild time, but there was also a baby in the lab, which I think, babies bring smiles.
It was a lot of fun to have your whole family there with us in the summer. Do you have any advice for students that are in high school now about entering college or preparing to enter college?
Just pursue your interests, right? And so if it interests you and you want to learn more about it, do that, right? I know that now I'm saying this and you're like, okay, well, you're a computer scientist, and some of you are like, my school doesn't even offer computer science, or I can't get into computer science until later. What am I going to do now? And really, to prepare for a computer science degree at UT Austin, you do not need to have already had computer science. We are aware that a large number of high schools do not offer it, and we do not expect you to have had it when you get here. So we will train you from the ground up. We don't expect any knowledge. What you can do to prepare is you can take your math classes and take your science classes, right? So as you learn mathematical techniques, those are really, our computer science department grew out of the math department. So these fields are very closely related, and we're in the College of Natural Sciences. And so, we're a scientific discipline in so many ways. And so, so these areas can really help prepare you for coming into the computer science department.
If you don't have the opportunity to take computer science at your school, a focus on math and science is really important. I'd like to thank Alison for your time today. We really appreciate you spending some time and explaining what you do, and you have such an impact on our students. So thank you so much, and I look forward to seeing you again in the future.
Yes, thank you. I also look forward to seeing you.